A senior executive logs out for the weekend. The office is empty. But hours later, a quiet string of data leaves that empty desk, and $250,000 vanishes across the network. Welcome to the reWant Courseware series, an AI-narrated technology video series unpacking the latest lectures and thoughts from Professor Adam Scott Wandt, coming to you today from the John Jay College of Criminal Justice. In modern financial crimes like business email compromise, the attacker rarely sets foot in a physical building. The entire event, from the initial unauthorized access to the final wire transfer, happens across the wire. That makes the network itself both the active crime scene and our primary source of evidence. Intercepting network traffic is a standard technical process, but turning those raw packets into admissible evidence requires a double layer of authentication: documented legal authority to conduct the capture, and a rigorous mathematical proof that the data remained pristine from the moment it was collected. To start that examination, investigators need to freeze the volatile network traffic. We do this through a packet capture, or PCAP file. This is a direct interception of the individual data units traveling between computers, recording the exact source, destination, and content of the communication. Because digital evidence is inherently fragile, we have to lock it down immediately. At the exact moment of collection, examiners apply a SHA-256 cryptographic hash to the PCAP file. This generates a unique alphanumeric fingerprint for the data. If even one byte of that file changes later, the hash will change, instantly breaking the chain of custody. With the original evidence secured, we use standard diagnostic tools to understand where the malicious traffic went. A utility called ping verifies if a remote computer is actually online, while tracerroute maps the exact physical path the connection took to get there, watching the signal hop from router to router across the globe. But those tools mostly show us numbers. To find out who actually owns the infrastructure at the end of that path, investigators use NSLOOKUP. This command translates readable domain names, like a fake banking site, into their true IP addresses, exposing the external servers the attacker is using to run the fraud. When the cryptographic hash and the physical routing data are documented together, they create a verifiable timeline. This forces any challenge to the evidence to address the hard mathematics of the capture, rather than general claims that the logs were simply altered after the fact. To read the actual intercepted data, examiners load the PCAP file into Wireshark, the industry-standard packet analysis software. A raw capture file contains millions of background connections, routine web browsing, printer updates, email syncs. Wireshark gives us the ability to cut through the noise. Instead of reading line by line, investigators apply specific filters. For instance, filtering for TCP port 4440 specifically isolates HTTPS traffic. This instantly hides the background chatter and brings the attacker's secure, encrypted web sessions to the surface. Once a suspicious connection is identified, we use a command called follow TCP stream. This strips away the technical routing headers and reconstructs the application layer conversation. We stop looking at packet numbers and start looking at the exact text, stolen passwords, or file transfers the attacker sent. In massive corporate breaches, there is often too much data for a human to parse manually. Investigators increasingly rely on AI-assisted models that can process thousands of packets per second to flag subtle anomalies. But AI outputs are leads, not facts. Every single flagged connection requires strict human validation before it can be submitted as evidence. Examiners also watch for traffic hitting ports like 9001 or 9030, which are commonly associated with the Tor network. While these connections don't reveal what was sent, they flag a deliberate attempt to anonymize traffic, a signal that often directs investigators to search the device's browser history for links to dark web marketplaces or cryptocurrency wallets. Looking at a network capture is ultimately about translation. You take millions of rows of raw, automated machine language, filter out the normal business operations, and extract a clear, human-readable timeline of a criminal's intent. Knowing how to intercept and read network packets does not give you the right to do so. Under federal laws like the Computer Fraud and Abuse Act, technical capability is entirely separate from legal authority. Capturing data without explicit permission is a federal crime, regardless of your investigative intent. For corporate fraud examiners, this boundary is defined by the private search doctrine. If an examiner oversteps an employee's documented expectation of privacy, say by capturing personal web traffic without authorization, that evidence becomes useless in a criminal referral. Law enforcement operates under a different set of rules, and they are increasingly using reverse search warrants to identify unknown suspects. Instead of targeting a specific person, investigators serve tech companies with a geofence or keyword warrant. This legally compels the provider to hand over data on every user who was in a specific location or who searched for a specific term at the time of the crime. This mass collection tactic has triggered major Fourth Amendment challenges. In cases like United States versus Smith, federal courts are actively debating whether these reverse warrants violate constitutional privacy protections by sweeping up the data of innocent bystanders. If an investigator builds an entire attribution chain based on a geofence warrant, and a judge later invalidates that warrant, the entire case collapses. In digital forensics, fluency in the evolving legal standards is a hard requirement. If the collection is illegal, the technical analysis doesn't matter. If you found this breakdown helpful, be sure to like, follow, and subscribe. Until next time, stay curious and want knowledge.